ready to dive into the emergence of everything,
Oh, wow.
from the Big Bang to the evolution of the mind.
Well, I think you're going to be fascinated by this. We're essentially going to trace the entire history of the universe
Okay.
from the very first moments to the development of consciousness.
Oh.
And we're going to see how a set of recurring modularity principle
Modularity Brain.
formulated by Carlos Perez, they played a key role in this incredible journey. It's like uncovering a hidden code behind the universe's creativity.
I'm intrigued already. So are we saying that there's some kind of underlying structure to how complexity arises?
Yeah.
From the formation of galaxies to the workings of the human brain?
That's exactly it.
Okay.
And what's amazing is that we can start to see these principles at work right from the beginning.
The beginning.
With the Big Bang.
Okay, hold on. The Big Bang. I usually associate that with just pure chaos and energy.
Right.
Not structure and principles.
Yeah.
How do modularity principles fit into that picture?
It's all about looking for those fundamental patterns
Okay.
of organization. In the first instance, after the Big Bang, you have this incredible burst of energy that cools and condenses, and it gives rise to a sea of elementary particles,
Okay.
the fermions. But it's not just a random soup of particles.
Right.
The universe has a way of organizing itself, and that's where bosons come in.
Bosons. Those are the force carriers, right?
Exactly.
Like photons for light and gluons for the strong nuclear force.
Exactly. And the key point here is that bosons act as the binders of these distinct particles, creating relationships and structures. You have something that binds and something to be bound. This, in essence, is Perez's first modularity principle.
So even at the subatomic level,
Yes.
we see this principle of modularity, this fundamental relationship between distinct entities and the forces that connect them.
Precisely. And it's not just about those initial particles. From those early interactions, gravity emerges,
Right.
shaping space-time and influencing how matter interacts on larger scales. And we can't forget about entropy,
Oh, and entropy.
the universe's tendency to move toward greater disorder.
Entropy as a modularity principle. I always thought of entropy as a force for chaos, not structure.
Yeah.
How does that fit in?
Think of it this way. As entropy increases, the universe has more potential for complexity. Perez describes this as the second principle. The universe evolves in the direction of higher entropy. It's this drive towards higher entropy that pushes the universe to explore new configurations and possibilities.
So entropy isn't just about things falling apart. It's about creating the conditions for new things to emerge.
That's a great way to put it.
Okay.
And as the universe evolves, we see gravity pulling matter together, forming the first stars.
Okay.
Inside these stellar furnaces, nuclear fusion creates heavier elements, enriching the universe with the building blocks for planets, and ultimately life itself.
So stars are like giant element factories powered by gravity and nuclear fusion. It's pretty amazing.
It is, and when these stars eventually run out of fuel, they explode.
Yeah.
As supernovas, scattering those heavier elements across the cosmos, it's a cycle of creation and destruction,
Right.
driven by the interplay of forces.
And this is where modularity comes in again. I'm
Exactly.
starting to see the pattern here.
The fourth principle of modularity states, competitive forces lead to decomposition that then leads to new composite creations. Supernovas embody this principle perfectly.
Okay.
The competition between gravity and nuclear forces leads to the star's collapse and explosion, ultimately creating new elements and seeding the universe with the ingredients for future complexity.
So we've gone from the Big Bang to the formation of stars.
Yeah.
And the creation of heavier elements. But if gravity is always pulling things together, wouldn't the universe just collapse into one giant clump?
That's where repulsive forces come into play.
Yeah.
Think about the repulsion between, charges or the weak nuclear force. These forces prevent everything from simply clumping together, ensuring that the universe remains diverse and dynamic.
So it's not just about what can bound, but also what chooses to stay apart.
Absolutely. And this brings us to Perez's fifth modularity principle. Relationships are selective.
Okay.
This selectivity plays a crucial role in shaping the universe.
Got it.
It's why we have such a diversity of elements and compounds.
Okay.
The Pauli exclusion principle, for example, governs how electrons interact
Right.
and plays a key role in the structure of atoms.
So these repulsive forces and selective relationships ensure that the universe doesn't become a homogeneous blob.
Right.
It's fascinating how these seemingly simple principles have such profound implications. But how do we get from atoms to the complex molecules that make up life?
Yeah.
I'm guessing water plays a crucial role here, right?
You're absolutely right. Water acts as a medium for interaction and innovation, allowing atoms to form complex compounds and setting the stage for the emergence of organic chemistry.
Okay, so we've got atoms swirling around in this primordial soup,
Yes.
forming more and more complex molecules.
Yeah.
But how do we go from those simple building blocks to the incredibly complex structures that characterize life?
That's where things start to get really interesting. And that's where we'll pick up in the next part of our duck dive. We left off talking about this primordial soup of increasingly complex organic molecules.
Right.
But how do we get from that to the highly organized, self-replicating systems we call life?
Yeah, it's a big jump.
It is a huge jump. Well, this is where modularity steps in again, playing a crucial role in this incredible leap.
Okay.
Imagine those complex organic molecules like amino acids
Okay.
as individual building blocks.
Like Lego bricks, ready to be snapped together into something bigger.
Exactly. And just like Lego bricks need a specific environment to connect those amino acids, needed the right conditions to interact and form larger structure.
Okay.
What's fascinating is that proteins... Yeah.
Those long chains of amino acids
Right.
actually create their own fluid environment, facilitating further innovation.
So it's like a self-contained ecosystem for building even more complex structures. It reminds me of how atoms needed that high-energy plasma after the Big Bang, and then compounds needed the fluidity of water.
That's a great observation. And as these complex proteins formed, along came another key player, lipids.
Lipids.
Lipids are like the architects of boundaries,
Okay.
forming cell membranes that encapsulate these complex processes and create distinct self-contained units,
Okay.
the first cells.
It's like building walls around our molecular Lego creation, defining a clear boundary between the inside and the outside.
Exactly.
But we still need the blueprint, the instructions
Right.
that guide the assembly of all these complex components. Where does that information come from?
That's where DNA takes center stage.
DNA. Okay.
Think of DNA as the instruction manual,
Oh, yeah.
the code that dictates how proteins are built and how cells function.
It's a robust, error-resistant encoding mechanism that enables life to replicate and preserve learning across generations. This is what Perez calls the 10th modularity principle. Robust, error-resistant encoding enables replication and preserves learning beyond the timelines of individuals.
So DNA is like the ultimate modularity principle for life. It's the information storage and retrieval system that allows complexity to not only emerge, but also to be cast on.
Exactly.
But how do those simple, single-celled organisms eventually evolve into the incredible diversity of life we see today?
Yeah.
Seems like another huge leap.
And you're right, it is. But once again, modularity plays a crucial role in this evolutionary journey. One of the key processes is endosymbiosis,
Endosymbiosis.
where simpler prokaryotic cells merge to form more complex eukaryotic cells.
Okay.
It's a beautiful example of cooperation and modularity at a cellular level.
So instead of just competing for resources, these early cells started cooperating and merging. I'm seeing a recurring theme here. Conflict and competition leading to destruction, but also to the emergence of new possibilities through modularity.
Exactly. And the amazing thing is that these mergers weren't just about combining resources.
Right.
They were about integrating entire systems. The mitochondrion, for example.
Mitochondria.
The powerhouse of our cells
Right.
has its own DNA,
Oh, wow.
a remnant of its independent past as a free-living bacterium.
It's like cells learn to outsource energy production by incorporating a whole other organism. Talk about efficiency.
It's a brilliant example of the 11th modularity principle. Intelligence by symbiosis of complex capabilities is learned by other individuals under different contexts.
Wow.
Cells essentially learn to reuse existing components for new purposes,
Okay.
creating a whole new level of complexity and efficiency.
This is mind-blowing. It's like evolution itself is a master tinkerer, constantly experimenting with new combinations and integrations, driven by these principles of modularity.
Yeah.
But is cooperation the only driving force behind the evolution of complex life?
Cooperation is a crucial factor, but it's not the whole story. Evolution often proceeds by building upon what's already available, what's called the adjacent possible.
The adjacent possible.
It's like a game where you can only make moves that are one step away from your current position.
So new possibilities emerge as the context changes. Kind of like how the universe couldn't have heavier elements until stars created them through nuclear fusion.
Precisely. It's the 12th principle of modularity. Innovation is contextual, complex, or simple. Solutions are driven by what is possible and not necessarily what is simple.
Hmm.
The emergence of heavier elements wasn't about them being simpler.
Right.
It was about them becoming possible within the evolving universe.
Right.
And the same principle applies to the evolution of life.
Okay, so we've got competition, cooperation,
Yeah.
and this concept of the adjacent possible all driving the evolution of increasingly complex life forms.
Yeah.
But how do we get from these early multicellular organisms to the development of intelligence?
Yeah.
Where does that fit into this modularity picture?
That's where we start to see a shift.
Okay.
From simple reactive behavior
Right.
to something much more profound.
Yep.
The ability to anticipate the future and act accordingly.
Yeah.
This capacity for prediction is a defining characteristic of complex life.
Wow.
And it's deeply intertwined with the principles of modularity.
Anticipating the future. That sounds like a huge leap in cognitive ability.
It is.
What kind of modularity principles are at play here?
This is where Perez's 16th modularity principle comes in. Adaptive behavior relies on predictions of the future.
Okay.
Think about it. Even simple organisms need to predict things like where food will be,
Right.
or where predators might lurk.
So it's not just about reacting to the environment. It's about anticipating what's coming next and making decisions based on those predictions.
Exactly. And as life becomes more complex,
No.
so too do the demands for predictive power.
Right.
This drive towards more sophisticated predictive abilities fuels the evolution of the brain itself.
Oh.
From the basic brainstem
Okay.
to the more complex limbic system,
Right.
and eventually the neocortex.
So our brains are like prediction machines.
Yes.
Constantly trying to anticipate the future and make sense of the world around us. That's a pretty wild thought.
It is.
And I'm guessing modularity is key to how these increasingly complex brains develop.
You're right on track. Think about how the brain is structured. It's not a monolithic entity,
Right.
but a collection of specialized modules,
Okay.
each handling specific tasks. The visual cortex processes visual information.
Okay.
The auditory cortex processes sounds, and so on.
Right.
This modularity allows the brain to handle a vast amount of information in parallel, making it incredibly efficient and adaptable.
It's like a well-organized company.
Yeah.
With different departments specializing in different tasks, all working together to achieve a common goal.
That's a great analogy. And just like in a company, communication and coordination between these modules are crucial for the brain to function effectively.
So we've got these specialized modules,
Yes.
each handling a specific task, all working together to create a cohesive experience of the world. But how do we go from that to the emergence of consciousness,
Yeah.
that sense of self-awareness that seems to set humans apart?
That's a question that has fascinated philosophers and scientists for centuries.
Yeah.
And it's one we'll delve into in the next part of our deep dive,
Okay.
exploring how those same principles of modularity might hold the key to understanding the emergence of consciousness itself.
We've journeyed from the birth of the universe
Right.
to the evolution of the brain,
Yeah.
all through the lens of these fascinating modularity principles. It's incredible how these recurring patterns seem to underpin so much of what we see in the world around us.
Yeah.
But perhaps the most mind-boggling question of all
Yeah.
is how we go from complex brains to consciousness. That
Right.
sense of self-awareness that feels so unique to humans.
It's a question that has captivated thinkers for millennia. And while we may not have all the answers yet, the principles of modularity offer some intriguing insights into how consciousness might emerge from the complex interplay of brain modules. Remember how we talked about the importance of prediction in the evolution of the brain?
Absolutely. It's like
Yeah.
our brains are constantly trying to anticipate what's going to happen next,
Right.
building models of the world to guide our actions.
Exactly. And as social animals living in complex groups, humans faced an even greater challenge,
Okay.
predicting not only the environment, but also the behavior of other individuals.
Right.
This is where social intelligence comes into play,
Okay.
and it's intricately linked to the emergence of self-awareness.
So by trying to understand the minds of others,
Yes.
we inadvertently develop a sense of our own minds. That's a fascinating idea.
It is, and it's here that we encounter Perez's 18th modularity principle. Social cognition becomes essential to survival. To navigate the complexities of social life, our ancestors needed to develop the ability to simulate the minds of others, to understand their intentions, beliefs, and desires. This capacity for mental modeling is thought to be a key stepstone towards self-awareness.
So in essence, by trying to predict and understand the behavior of others, we end up turning that same predictive power inwards,
Exactly.
developing a model of our own minds. It's like looking into a mirror and suddenly recognizing yourself for the first time.
That's a wonderful analogy. And this recognition of self, this
Right.
capacity for self-reflection,
Yeah.
is what Perez identifies as the 19th modularity principle. Mental models of self lead to consciousness. It's the culmination of this incredible journey from the Big Bang to the emergence of self-aware beings.
So from the very first interactions of particles after the Big Bang
Yeah.
to the complex workings of the human mind,
Right.
it's all connected by these principles of modularity. It's like uncovering a hidden code behind the universe's creativity.
It truly is a remarkable story. And what's even more fascinating is that these principles aren't just about understanding the past.
Okay.
They can also guide our future, especially when it comes to one of the most transformative technologies of our time,
Yeah.
artificial intelligence.
Okay. Now that's something I'm really curious about. We've talked about how modularity shaped biological evolution,
Yes.
but how can it help us build truly intelligent machines?
If we want to create AI systems that are not just powerful, but also adaptable, creative, and perhaps even conscious,
Yeah.
we need to look beyond simply replicating the structure of the brain.
Okay.
We need to embrace those same principles of fluidity, boundaries, and permanence that have driven the evolution of complexity throughout the universe.
So instead of focusing on building a replica of the human brain,
Yeah.
we should be focusing on embodying these fundamental principles of modularity in our AI systems.
Exactly. Think about those key principles we've been discussing. Decomposition,
Go ahead.
breaking down complex problems into smaller, more manageable modules.
Right.
Mediation, ensuring effective communication and coordination between those modules.
Got it.
And perhaps most importantly, late binding,
Delay binding.
allowing for flexibility and adaptability by deferring decisions until the last possible moment. These are the building blocks of truly intelligent systems, whether biological or artificial.
It's almost like giving our AI systems the same tools that the universe used to create everything from stars to brains. We're essentially giving them the power to learn, evolve, and create on their own.
Right.
But it also sounds incredibly challenging.
It is. Building truly intelligent machines is one of the most ambitious goals we can pursue as a species. But by understanding and leveraging these fundamental principles of modularity, we can move closer to that goal, creating AI systems that are not just tools, but partners in shaping a better future.
This has been an incredible journey. From the Big Bang to the frontiers of AI, we've seen how modularity principles have shaped the emergence of everything. It's given me a whole new perspective on the universe and our place within it.
I'm thrilled to hear that. And as we conclude this deep dive, I want to leave you with a final thought. If modularity is so fundamental to the universe, how can you consciously leverage these principles in your own life? How can you embrace fluidity, boundaries, and permanence to become more adaptable, creative, and resilient? It's something to ponder as you continue your own exploration of the world around us.